Assalamualaikum warahmatullahi wabarakatuh. Welcome to Chapter 8, Probability. In this video, we are going to understand the concept of experiments, outcomes, sample space, events, and random selections. Let's start off by looking at the definition of probability. When we are talking about probability, we are talking about the likelihood of something happening. Now let's look at some of the vocabulary that is used in most cases. The first basic term is the random experiment. Random experiment is a process which ends with two or more possible outcomes where the result can not be predicted. We do not know which outcome will happen. Typical examples of a random experiment are roll a die. The outcome can be either 1, 2, 3, 4, 5, 6. The second example, toss a coin twice, or just simply toss a coin. Suppose a coin is tossed, the result is going to be a head or a tail. The number of possible outcomes is 2, a head or a tail. The next example is take a driving test. The result will be either you pass or fail the test. In each of these examples, you can specify the possible outcomes. However, we do not know which outcome will occur. We call all the possible results from a random experiment as weighted outcomes. Back to the first example that we see the previous slide is roll a die. The outcomes may be either 1, 2, 3, 4, 5, or 6. The outcomes for tossing a coin twice, you could get a hit from the first toss and hit from the second toss, or you can get hit from the first toss and tail for the second toss, or you can get tail for the first toss and hit for the second toss, or you can get both tails for the both tosses. For the next example, when you take a driving test, the outcomes, you can possibly fail or pass the test. Now let's look at sample space, symboled as capital S. The sample space is a set of all possible outcomes of an experiment. It can be illustrated by either in a list or in a set of lists like this. Or you can write it in a table, or you can get all the sample space from a tree diagram. Events is a collection of one or more outcomes from a sample space. It is a subset of the sample space, also denoted by a capital. Example 1. The first experiment is roll a die. So the possible outcomes are 1, 2, 3, 4, 5, 6. So the sample space are all the possible outcomes, which are 1, 2, 3, 4, 5, 6. Let's say I create an event. For example, events of getting odd number. So from the list of the sample space here, the odd numbers are 1, 3, and 5. Let's move on to the second example. Toss a coin twice. We can see the whole sample space for this experiment in form of tree diagram. If a coin is tossed twice during the first toss, there are two possible outcomes, either a head or a tail. Now, if we got a head in the first toss, in the second toss it can be a head or a tail. And then, if we got tail in the first toss, it could be head or tail in the second toss. We're going to get four possible outcomes. So, if we go in this direction, the first outcome is head and then head. If we go in this direction, the second outcome is head and then tail. If we go this direction, the third outcome is tail and then head. Lastly, if we go in this direction, the fourth outcome is tail and then tail. So here I can list down all the animals inside the sample space, which is HH, HT, H, and E. So we can see there are four possible outcomes when toss a coin twice. Now, let's take an event from the sample space. For example, events of getting a head and a tail. So, from the four outcomes, you can see the head and tail is from the third outcome and the fourth outcome. So there are two outcomes for events of getting a head and a tail. Next example, take a driving test. The outcomes are either you pass or fail the test. So the sample space will be either pass or fail. Let's take an example of an event from the sample space. Then A, for event of getting pass, the only element that we have in the event is just pass. Example 2, list a sample space when two dice are used or a die used twice. Hence, find A, total number of outcomes, or the N of S. B, number of outcomes is sum of two numbers is 6. C, number of outcomes is sum of two numbers is 1. Let's think about the sample space. I could use a tree diagram to figure out all the possible outcomes after tossing the dice. It will be like that, but I think it is better to use contingency table here. Now, what can we get from the first die? Well, it is a 6-sided die. They are numbered from 1 to 6. Next, let's think about the second dice. 1, 2, 3, 4, 5, or a 6. Now, given these possible outcomes of the toss, we can now think of the outcomes of both dice. All of this top row, these are the outcomes where I get a 1 on the first die. These are all of the outcomes where I roll a 2 on the first die. This is where I roll a 3 on the first die, 4, and so on. You can see here there are 36 possible outcomes. 6 times 6 possible outcomes. Now with this out of the way, how many of these outcomes satisfy our criteria of getting the sum of two numbers is 6? So we start with let's A as an event of getting the sum of two numbers is 6. Therefore, we list down from all the outcomes. You can see 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. We count here 1, 2, 3, 4, 5. The number of event E to happen is 5. Question C. Number of outcomes getting the sum of two numbers is a multiple of 5. So we have to add up the outcomes from first and second die, and then if we get the answer as a multiple of 5, that will be the event. So we start with let P as an event of getting the sum of two numbers is a multiple of 5. From the contingency table, we can see that the first outcome, that sum of these two numbers, the first outcome is 1, 4, because when we add up 1 and 4, 1 plus 4 is 5. So 5 is a multiple of 5. The second outcome is 2, 3. When we add up 2 plus 3 is 5, then 5 is a multiple of 5. The next outcome is 3, 2. Next, 4, 1, 4, 6, 5, 5, 6, plus 4. 6 plus 4 is 10, and once again 10 is a multiple of 5. So now we can count all the outcomes from the event P. 1, 2, 3, 4, 5, 6, 7. So the amount or the number of getting sum of two numbers is a multiple of 5 is 7.